lab instructor have already tested you on that. Here, more into like the function of bone in general. Although, there's something that I want you to know, the anatomy of bone, things like, here the diaphysis, the epiphysis, mm, um, and just the general term that we should know, functional units of bone is known as osteon. And in the lecture, we might do a um, little more details in terms of what osteons are, or what is an osteon. An osteon, of course, you should know, is to make out the concentric lamellar plate. Like you would say here, something like this, lamellar plate. And I ask you to remember there are three kinds of lamellar plate. The one that is part of that osteon that you can see here. These are known as your concentric lamellar plate. If it's between the two osteons, this is interstitial lamellar plate. And then the one that is outer edge is known as circumferential. Okay, so that's a good place also to start studying, looking at, examine the osteon and the lamellar plate. And I asked you to know a little bit more about the component of what is bone, right? Bone has a bone matrix, and which is basically is hydroxyapatite, and which is basically a lot of bones have that bone matrix, which is composed of the mineral part. And then there's only the small part, only like 5% of them are protein. And the major protein, of course, is your collagen. Okay, so that's a good thing to learn too, the bone matrix. Let me see if I can find that slide for you. I can't find it, but I think it's in there somewhere. The cells of, here, there's a bone matrix. So this is also good areas to study. What is bone made out of? 2/3 of it is mineral, and 1/3 of it is protein matrix, which is mainly collagen. Okay. The cell that made of the bone, things like the osteoblast, or the cells that lay down the bone, osteoclast that chews up the bone, osteoprogenitor cells. You see here is the same thing as mesenchymal stem cells, and osteocyte or mature cells that osteoblasts get trapped. Okay, they become osteocyte, and they are found in this little lake, like we call it lacunae. So these important cells that you need to know. And we start learning in terms of two ways in which how bones are made. Typically, bone in the neck up is made by what process? Abdu, are you there? Yeah, Abdu, what's the answer?
Can you repeat again, please?
The question is that the flat bone, like the frontal bone here, is made by what process?
Well, like ossification?
Yes, what kind of ossification?
I don't know, to be honest.
Okay, good. So usually I mentioned to you bones from the neck up is made by the intramembranous ossification. Right? And the step that is involved, start learning them, which would be like involving mesenchymal stem cell that's recruited to that area, and then that mesenchymal stem cells become osteoblasts that lay down the bone, and it forms this spicule surrounded the blood vessel, so then that becomes spongy bone. And then the bone get restructured. Okay, so the steps that is involved in making that intramembranous ossification, start learning about that. Okay. Um, okay, now that showed you here intramembranous mesenchymal stem cell recruited, osteoblast, uh, mesenchymal cell become osteoblast to lay down to form the bones that forms this key word here, spicule, that's surrounding the blood vessel, and then they produces more to become spongy bone, and then you get the remodeling. So these are the 5 steps that you guys should be studying in terms of intramembranous ossification. Now, bone from the neck down, with the exception of clavicle, is made by what process? Adriana. Oh, Abdu. It's made by what process?
Endochondral.
Yeah, so complete the thought. It's endochondral ossification, okay? Not just endochondral. Good. And the word endochondral, let me ask Adriana. What does the word endochondral mean, Adriana? Okay, Adriana doesn't know. Adriana, not sure. Okay, Ashley. Endochondral meaning what? I don't know. Okay, so the word endo mean inside. Endo. So chondro refers to chondrocyte. And chondrocytes made up of chondrocyte made cartilage. Right? Cartilage. And cartilage is the connective tissue, specialized connective tissue that you saw that. Okay, so in long bones development, for example, you start out with the base, which is the cartilage. So if you take the fetus skeleton, hasn't been calcified yet. It is cartilage, it's cartilage, and then it get calcified. By calcify meaning that usually the cartilage or the outside called the perichondrium might forms as a collar, for example. But the first things that you see with the endochondral ossification is that the chondrocyte become enlarged. Okay, a cell that's enlarged is hypertrophied. Then that cells hypertrophies might bring some blood vessel into that area. The blood vessel bring oxygens and nutrients to that area. And then in doing so, you might have some osteoblast that comes in that lays down the bone, and then the hypertrophizes chondrocyte get calcified and they die. And then you have your osteoclast that comes in that restructure it. Okay, so and that is showing you in this process here, where you can see that this is a cartilage model, and they get hypertrophied. You see here, these are chondrocyte blood vessel that comes in that lays down the bone. And you can see here is that typically in the long bone development, the ossification, the area that become first, that you see, they become first here. This is known as the primary ossification center. And later on, you get another ossification over here. This is known as secondary ossification. Okay. But the primary ossification occurs in the diaphysis. Okay. primary ossification. All right, so I write this down. Primary ossification is, and then the diaphysis, and then I don't know, can you guys see that? Secondary ossification is at the epiphysis. Can you see my handwriting over? Can you see my writing up here? Okay, good. All right, great, thank you. I don't know how to make it larger. Good. So make sure you know that. And here are the steps that is involved in endochondral ossification. Chondrocyte enlarge, calcify, blood vessel enter, perichondrium converted to periosteum, and that's sort of like all this that forms as the collar at the end. Osteoblasts lay down the bone, and then here you get osteoclasts that chews up the bone. Okay, and then you can go through these steps and shows you exactly what happened there. And here, this is the primary ossification center that occurred within this. This is diet. Okay, and what you can see here is these are bone. Bone is here, right? But cartilage is still up here. This is still cartilage. And bones here. And then this is the secondary ossification center. You start here, and then this area that get ossified. But this still here, the blue one here is still cartilage. And this is important because if this bone starting to get a lot of growth hormone, they stimulate the long bone growth, they get growing and growing and growing. And ultimately, here's adult bones with C. And this is the critical point right here. Okay, this is a critical point. Here is known as the epiphyseal plate. The presence of this epiphyseal plate here, as you can see, they're just stack of chondrocyte. Okay, they're stacks of chondrocyte. Are you using PowerPoint? Can you see my arrow now? I think no. Okay. How about now? Okay. All right. I have to click on this guy. Alrighty. All right. Thank you. So this right here is known as the epiphyseal plate. Okay. The epiphyseal plate have stack of chondrocyte. And if you enlarge this area, it looks like this. Okay. And this is a critical area because I will probably, I don't know, I like you to learn about this area and having these, the event that occurring. For example, this end over here, we call this as diaphysis, and this end over here is called epiphysis, right? And in this area here is that you can see that the cells started to grow, the chondrocyte that grow, and then they're actually going to, they're going through various stages, but the important thing is this. I see the point, but I don't hear you. I don't know why you don't hear me, man. Can you guys hear me okay? Okay, so I'm not sure why you didn't hear me. Okay, maybe you can turn up your micro or your speaker. I was going to write this down for you too. Is that how do you know when the long bone reaches maturity? Okay, so long bone reaches maturity when there is a closure of the epiphyseal plate. Okay. And by closure, right now, this bone is long, this bone is continue growing because the epiphyseal plate is open like this. That you see a layer of chondrocyte. When you don't see any more layers of chondrocyte right here, so that you can say the primary ossification and the um, second ossification center sort of like meet together. So now you have this one line that goes straight across. That is known as closure. And when that's occurred, then bone doesn't get longer anymore. But even you get more growth hormone, then you get what considered as apposition growth. Apposition growth means that they're going to go wider. Right? I don't know if you guys remember what the disease I told you that in adult, if they get a lot of growth hormone, their hand will get really big. They get protruding jaw, like Andre the Giant. What is that disease is called? Does anybody know? No, not gigantism. That's the different. Okay. Gigantism is when a child has too much growth hormone and he will go really, really tall, 6 feet, 7 feet, 7.1, maybe 8. No, not 7.2. And that is, I don't know if you guys who know is minute bull is. So that's the key difference. I'm going to write it here too. Too much of growth hormone in children will lead to gigantism, but too much growth hormone in adult. And how do you know adult and children? In adult, this thing is closed. In children, it's still open. So in adult will lead to a condition known as acromegaly. Okay, acromegaly. Okay. So I'm going to show you then. Okay. So this is here is now is like this is basically at puberty. It shows you that they're started to close up. Okay. This is your primary ossification center that get lengthened, and it joined with the secondary ossification center, and you still have this. In adult, this will close up. Another important distinction of the that you often see with long bone development is that the end that you see here do not get ossified, so it's remaining cartilage. So typically long bone, this is considered as your articulating cartilage because they're joining with another. If there's the humerus, it is articulate with the glenoid cavity of the scapula, for example. But all that is just cartilage. And good thing to know also, this is the compact bone that you see here. Most likely the osteon is found in the compact bone, not in these bones. This is spongy bone. So the trabeculae, all these spongy-like trabeculae here is part of the spongy bones, spongy parts of the bone. So apposition growth really means the thickening of that, and typically is that you're getting more circumferential lamella, and this is occur when adult reaches actually a person reaches adulthood. The epiphyseal plate is closed. If you give more growth hormone, the bone will get thicker and fatter, for example. Okay. X-ray showing, see how you can see this arrow is pointing to this. This is still opening. So this is still a young kid growing. And then here would be is that they're really kind of disappear. So if it's disappearing, you don't see anymore. This is you can say it's one type of joints called synostosis, synostosis, meaning together bone, also known as a bony joint. I'm going to talk to you about a little bit. Okay. All right. Now, what happened at the epiphyseal plate? You have these layers of cells that you can see. Now, this is, so what you see here is this is the epiphyseal epiphysis over here, and down here is a diaphysis, and this is the epiphyseal plate. Okay, so the first layers of cell is the layer that is next to the epiphyseal, the epiphysis. They're resting cells. They're resting there, and then as you go toward the diaphysis, the second layers of cells, right here, okay, they're undergoing mitosis. What really means is they're dividing. So they're resting, they're dividing, okay, and they're dividing. As they get larger, they enlarge, hypertrophy, okay, and then when they get hypertrophy, and especially when they get bone around it or in it calcified, they're dead. So that's the four layers of cells I want you to know. You have one layer that is resting. The second layer is the cells are dividing. The third layer is that they're calcified, they're hypertrophied. The calcified mean they have calcium in there, and and then they're dead. And then essentially what happened is this osteoblast, a cell that lays down the bone, start laying down these. So they replace the dead chondrocyte with bone, and then the last thing you see is that the osteoclast that comes in and chews up that bone. Okay. And this is your osteoclast right here. Osteoclasts are multinuclear cells. They're involved in chews up bone. So bone resorption, there's two key words that it's good to know to distinguish. Bone resorption is choosing up the bone, okay, and it's under the influence of parathyroid hormone, whereas bone decomposition is under the influence of osteoblast, which is basically lay down the bone, and it is influenced by the hormone of calcitonin. And I believe I talked to you is this easy way to think of this in this context. Okay. So you can think of, all right. So there are two, maybe I'll do this as easy, okay? So there's two hormones, PTA, parathyroid hormone, and the other one is called calcitonin. Now, think of the PTH here, parathyroid hormone function is to increase your blood calcium. That's the easy way to think of this, okay? While the calcitonin function is to decrease your blood calcium. And I like to think of this, and I like my question to be thinking of this as well in exam question, for example. So if your job is, if your blood calcium is high and you wanted to bring down the blood calcium, what do? You store it in bone, right? So how do you store it in bone? You stimulate osteoblast. Okay, so you stimulate osteoblast. So then osteoblast then will put the extra calcium into bone, right? So on the other hand, if your blood calcium is low, you want it to bring it up. How do you bring it up? Well, you stimulate osteoclast, right? You stimulate osteoclasts, which chew up the bone. But another thing that you can also do is that calcitonin, in a big picture, the way that it decreases the blood calcium is that it stimulates the kidney too, to get rid of it through the urine. Okay, so we see that as well. So stimulates the kidney to excrete, I mean to get rid of calcium in your urine. Okay. So these are like two functions of calcitonin: stimulate osteoblasts and stimulate the kidney. PTH, on the other hand, has three functions, right? One, stimulate osteoclast to chew up bone. Two, it stimulates the kidney, not to get rid of, but to take back, to reabsorb. We call this to stimulate kidney to conserve or to save, or the term that people use called reabsorption. Okay. So the way the kidney does is that it filters your blood calcium and all the waste and stuff in your blood. It filter all that up first, and then it takes it back. We call that reabsorption. Like it probably filter glucose out of your blood, but then it takes it back up again, all of it. If it's too much, then it can't take it all back. Then that glucose is end up in your urine. But typically, if you want more calcium, then it tells the kidney, do not get rid of the calcium because we need that. So that increases it. So what's the third way that PTH might try to increase your blood calcium? What's the third way? Avi? Avi, can you hear me?
Repeat the question one more time.
Okay, so PTH is trying to increase your blood calcium. One way is stimulate osteoclast, two is stimulate the kidney to take back the calcium. What's the third way?
I don't really know, to be honest.
Okay, Abdu, what's the answer?
Maybe the instant stand?
Huh?
Maybe the instant stand? Let to say that like that. Never mind.
Okay, let's try Celeste. Okay, you can say decreases the osteoblasts. Yes, you can do that, but that's not the major function. The major function is that you guys have your breakfast this morning, right? With cereal. You take cereal with milk. So another way that you can increases your blood calcium is that increases reabsorption through the GI, small intestine. Okay. So increases absorption through the small intestine. Okay. Abdul, you have a question? Abdul, you have a question? Okay. So the question then is that how does then PTH increase absorption of calcium to the small intestine? It does it through in conjunction with another vitamin. You know what that vitamin is? If you want to have effective absorptions of calcium through the small intestine, you need a vitamin. What is that vitamin? Good, vitamin D. Yeah, you need vitamin D. Okay, so let's finish up this thing if we can. We're going a little slow. And then we're going to start on the nervous system. Okay. Okay, so the 4 layers of cell that you I expect you to know are the resting cell, the dividing cell, the hypertrophied cells, and then the dead cells. All these occurs in the epiphyseal plate. Okay. The important hormone we talked about already are calcitonin and PTH that involve in ossification, either endochondral or intramembranous ossification. And here it shows you the hormones of PTH. How it does is trying to increase your blood calcium, stimulate osteoclast, get reabsorptions to the small intestine, and take the kidney to conserve or to take back calcium. Okay. On the other hand, so factor that increases the blood calcium is the opposite, and that's this hormone should be calcitonin here. And calcitonin does it by mainly to stimulate this osteoblast to put the calcium into the bone and to stimulate the kidney to get rid of that. And the absorptions to the small intestine is to the vitamin D. I'm not going to tell you that, go into detail how, what are the processes involved in making calcium and vitamin D, which is really start out with cholesterol and it get modified through the skin, and then the kidney further modifies it. Calcitonin, actually calcitonin comes from the C cells of the thyroid gland. Okay, so if you can recall in when we talk about histology, the follicular cells, so here's your follicle, here's a follicle. The cells that make up the follicle cells look something like this. So we consider it as simple cuboidal epithelial. Okay. And these cells right here put out T3 or T4, which is an important hormone for metabolism. Okay, T3 or T4. But the cell that sits outside here, called parafollicular, sometimes they know it's C cells right here. So the C cells is the cell that sit outside the follicle. They are producing calcitonin. And that's your follicle. Put out T3 or T4. Okay, so they can consider these are simple cuboidal epithelial. So these are parafollicular cells, and they put out calcitonin. You see here, calcitonin. All right. PTH, we already told about the functions of that, and here's the synthesis of the active forms of vitamin D. You really don't need to know that. That's probably too much. And vitamin D, if you don't, there's different kinds of vitamin. Vitamin C is important for collagen synthesis. If you don't have any vitamin C, you have fragile bone. You also get gums disease as well. It's known as scurvy. So, sailor in the old days, their gum tend to bleed a lot, and what they do is they bring a lot of citric fruit to get you vitamin C. So AC probably not in this exam, but D will be, because a lack of vitamin D will lead to conditions we call poor bone development, osteomalacia, and that is an example of that is rickets. And the common thing that you see in ricket is that because the bones in the leg do not form properly, it's like the word Malaysia means bad bone or soft bone, and the telltale sign is that they get bow-legged, right? Because the torso, the body is pushing on the leg, the femur, and the tibia. As such, it's kind of like bow-legged, if you will, like a cowboy would walk. We talked about already how not enough growth hormone or too much growth hormone in children will lead to gigantism, but in adult it's acromegaly. The opposite of that is that if it's not enough growth hormone, it leads to dwarfism, as you can see here. Okay. And then, of course, typically bones will get older. As you get older, the bone is going to get more fragile, particularly elder woman, menopausal woman, when she stopped menstruing, stop producing a lot of estrogen, she will get, her bones will look like a lot of holes in them. So we call that osteoporosis. And when she usually falls, fracture her hip, very common, you might have to have hip replacement. Okay. Let's do a couple more things, and then we're going to end it there. And then I just have to have a couple more things regarding the joints when we come back, and then we can start on our nervous system. And this is regarding the different types of fracture. You can see it here. The term is that when a bone that is broken and it displays, right, which meaning that it's not in this normal position, but it punctures the skin, right? That's known as the displays. Comminuted kinds of fracture, meaning that there are multiple fragments that you can see here. This is a good one to see, green sticks. Green stick is usually, as you would expect, like a green stick, you're trying to bend, but it doesn't bend. Maybe the edge, the circumferential lamella might just pop out like that. And that's usually seen in children, okay, the green stick type of fracture, because they haven't quite also strong yet, so that you can bend it a little bit. Okay. Transverse non-displacement, non meaning it hasn't been moved out. So transverse across. Oblique is basically more of a diagonal. So basically you get both impact from the top and on the side that give you that. Spiral is when, like a husband or boyfriend twist a girlfriend. Oh, that's Me Too movement. That's male. Okay, he shouldn't be doing that. A collie type is often seen. Yes, yeah, it is true. An example is, let's say, for example, if you rollerblading, we can't do it here because it's too cold. I'm in Indianapolis, but if you, let's say, in Florida, now it's nice and warm, 81 degree, and you're rollerblading, and all of a sudden you stop and you fall. What do? You usually brace yourself, right, like this, to kind of like to brace your impact of falling, I guess. And typically over here, your carpal bone is broken. That's your collie. Similarly, POT is a type of injury associated with sport. Like a football player may have the spiky shoes, and he might be planted on the artificial turf, for example, and he might hit on the side, something like this, so that you break the ankle, for example. That is known as the POTS. So those are the different types of fracture that I think you should focus on. POTS, collie, green sticks, and linear means just along the line. And it's usually impacted on something top that give you that linear. Okay. The X-ray show you kind of a similar thing. And then before we take a break, so typically the way that bone will heal takes time, but there are 4 steps that is involved in this. Is first thing that you see is, this area will have pools of blood. We call this hematoma. And this hematoma over time will form as what we consider as soft callus, not quite bone yet. And over time becomes spongy bone, and then remodeling, so come back to normal. So the healing process are hepatoma, soft callus, spongy bone, and remodeling. Alrighty. So I'm going to stop the recording there. Are there any questions?